Thank you, Diane, for your interesting session. It was very long, really, 30 minutes more than planned, but I hope that was useful and interesting for all participants. And now, in 2 minutes, we'll start our next panel. Which is on our future cities domain. We are working devoted on digital twin cities. It is very much related to the yesterday panel about data spaces. We'll have very good experienced people there. Tuomo from VTT, who is also a member of Big Data Value Association, this Task Force 10, which is dealing with data spaces together with Ed Curry. Also representative from Fireware. They're also members of this Big Data Business Alliance, providing data models and we're having our colleagues from Chalmers University. We're working together with Digital Twin City Center, a lot of common projects and activities and close work. And also Genco Cherezu from Sofia Municipality. Again, we're working closely on implementation in Bulgaria of this digital twin. And the panel will be moderated by Graham Kemp, who is from Chalmers University, and it's a partner in GATE project, and very close. We are working very close in GATE Institute together. So I see 1 minute. We are starting the panel. Just 1 minute for short grab a coffee and continue with the next interesting session.
So good morning and welcome to this panel session on city digital twins. I'm Graham Kemp from Chalmers University and I'll be the moderator for this session. Can I have my presentation, please? And I need to find the controls. Okay, got those here. So we'll be joined today by five presenters. First, we'll hear from Tuomo Tuika from VTT in Finland. He's the lead for data space solutions there, and I'm looking forward very much to hearing about his work. We'll then have four presentations from our panelists. We have Stefano De Panfilis, who is Chief Operations Officer at Fireware Foundation. So together, Tuomo and Stefano will be sharing with us their experience on technologies and approaches that promote and support the sharing of data. We'll then have two panelists who are both working closely with city digital twins. We have Desislava Petrova Antonova from the Gate Institute in Sofia, Bulgaria, who is leading the data management research efforts in the Gate Institute and also leading the Future Cities research application theme. And from Chalmers University of Technology, we have Professor Anders Log, who is Director for the Digital Twin City Centre at Chalmers. And finally, moving into real cities, we have with us Gensho Keresov, who is Deputy Mayor for Digitalization, Innovation and Economic Development of Sofia Municipality. But before we get underway with those presentations, I'd like just to say a few words about the Gate Institute together with the Digital Twin City Centre in Gothenburg. 1 year ago at the corresponding session, I mentioned a tale of two centres, and I mentioned how these two centres had both been launched around the same time and how in their early years they had been working in close cooperation. And at that time we reached the Gate Annual Forum 2020, where we had presentations from both centres. Well, a year has moved on and there has been some new growth, and in particular I'd like to mention that there have been two further workshops between Digital Twin City Centre in Gothenburg and Gate, where we've had researchers from both sides presenting their work and sharing their knowledge and expertise in the field. Also, more recently, there were presentations from both centres at an event of the Big Data Value Association, the European Big Data Value Forum. And here we are today with the second Gate Annual Forum. So it was just last week that both Anders and Desi participated in the European Big Data Value Forum. That was an online event, as was the second workshop of DTCC and Gate that was held back in February. We were still very much locked down at that time, and having an online workshop was the only option. The centres have been working in cooperation in various ways, but I'm just picking out here some of the main events where we have presented together. Last month, we were delighted to host in total 11 visitors from the Gate Institute who visited Chalmers for almost a full week. We had a series of workshops on different themes, both scientific and also looking at intellectual property, looking at business models and so on. But we were delighted to be able to spend almost a full day together working with our colleagues, with researchers, both at Chalmers and also the partners in Gothenburg from industry, from the municipalities, where we were able to share our expertise. Here we have some images of our colleagues from the Gate Institute presenting at this event in Gothenburg last month. But apart from this one-day workshop, we also were able to visit some of the facilities in Gothenburg. We were able to look, for example, at VR, virtual reality interfaces to twin cities. We were able to have workshops. We had a workshop focusing on data models in twin cities, also working groups looking at simulations within cities, and more wider general discussions among the group. So it was a great opportunity to have the chance to meet with so many of the GATE researchers in person, and hopefully building on that, we'll be able to have many more research-related conversations now in the months ahead. But back to today, and I would like to start this panel with a keynote presentation from Tuomo Tuika from Finland, and I invite you now please to share your presentation with us. And please check that you're unmuted.
Oh, really? That's a good point. Thank you very much, Graham. And may I have the first slide? All right. Well, anyhow, this is my second slide, but that's no problem. It's anyhow good morning. It is totally wonderful to be here with you today and give a talk about these data spaces in a smart city. So I'm Tuomo Tuikka and from VTT Technical Research Center of Finland. And as Graham said, I'm leading the topic of data spaces at VTT. But also besides that, I'm also BDAIF, Big Data Value Association, the Data Spaces Task Force co-chair and the VTT contact to GAIAX and IDSA. All right. So when we look at news, we can see that humankind has many challenges ahead, and I believe everyone has seen pictures from various parts of Europe when sudden water flooding in cities causes damage and threatens lives. Strange behavior of climate can also be seen here in Arctic, and my home is near the Arctic Circle, so we can see that the rivers do not freeze anymore as they used to do, and both flora and fauna are transforming to include more southern species. And flooding happens every year, but more snowfall increases the probability of more disastrous events. So this is sort of like the big picture where human settlements and how population behaves has a central role. And we have like many ways to be wiser in this matter, and one of them is to understand how our population centers impact the environment and how smart we can be to create a sustainable future. Therefore, smart cities is not a buzzword, but it is a requirement for our very existence. And smart city may mean that we use ICT for services, but smart city means that to have a way to understand how to design cities so that they are not vulnerable to disasters, reflect on impact on sustainability, and they are safe and secure, but take into consideration trust within society at the same time. So data space is rather new concept and which has gained huge attention due to European data strategy released in early 2020. And this concept has been seeking its definition, but that has not been preventing a lot of noise and buzz emerging. sort of like stick figure version of data space means like sectoral data sharing, coated with interoperability of information systems. Well, this is absolutely right. But when we start to think about it, the word is more complex. In this picture, you see a new tram line in the city of Tampere in Finland. The tram has just started operating this year and has been very much like traffic improvement in the city. As an example, data sharing will help us connect the different transportation modes into a seamless public transportation system that will improve users' experience as well as enable sustainable development and a smaller carbon footprint. So data sharing is a start for a data space. Now, what is striking is that when we start building information systems which now exploit data sharing and are sort of like embryonic data spaces, we need to start looking at things differently. The design of data space does not happen in silos, but it is an issue for the whole ecosystem to making sense of its goals, whether they are business goals or other benefits. The first thing to create the European data space is to do piloting and experimentation, connect data of ecosystem partners and design the ecosystem so that it complies with the regulation and values and approaches which are shared in Europe, and common standards which will support the building of digital market. This all happens at the same time now, and we are constructing a conceptual framework and learn from practice by building and experimenting. Now in Finland, we can see these developments in many cities, like in Tampere, as pointed out, especially in the transportation and traffic, and in Espoo, neighboring to Helsinki, an area called Smart Autonomy connecting facilities, transportation and energy solutions, and in the city of Oulu, where I locate, Oulu Data Space aims to make Oulu as the most measured city in Europe. Now, in this picture, you can see Tampere Smart Tram Living Lab, where real operating trams, test trams, and digital simulation environments meet. So this is a research data platform which collects all the test data from actual operations and combines and processes simulation test data and shares that with ecosystem parties. So currently, European scene on data spaces sees quite a lot of development, and especially this year, we have seen many alliances and groups forming and aligning European companies, research organizations, and associations for the forthcoming development on digital market. So national investments on digital technology support common European developments. It's like an investment sandwich, and challenges all the brilliant minds to think about this inescapable digital transformation. It's pretty much a must for European data economy to flourish. Here you see a depiction of three very important organizations to advance data economy. The first one being Big Data Value Association, which has been a public-private partnership concentrating on big data and artificial intelligence. And it brings together research and technology organizations, universities, and companies to lay out research scene for future developments in Europe. It provides a research agenda and follows the developments of European data and infrastructure related research project. And of course, we at BDVA reflect on these research projects, what is going on, and the community informed of reports and white papers. So on the left, you see the data sharing value wheel developed by BDVA community, which identifies core pillars for data sharing value. In the center is trust, which can be achieved in various ways, surrounded by aspects from governance, people, organizations, technology, and data. All of these have to be considered before the wheel of value can rotate. I hope you can see the slides. I can see that there's some delay with this. One very important notion here is that value is not only a matter of technology. Then there are technical developments in form of GAIA-X and International Data Space Association, and a colleague here is in this session is from FiveWare, and these approaches identify trust and sovereignty as central themes. They promote decentralized approach and look for standards enabling interoperability. Some differences do exist. This is my analysis here, and whether it is a matter of semantics or not requires a deeper look. But clearly, GAIA-X raises the notions of trusted and federated cloud, importance of edge, self-description, and in IDSA, connector component has a central role in connecting data spaces between stakeholders. There's a certification scheme to promote trust. Now work is undergoing, and there's a rule book to help designing data spaces. Now, what we learned here that data spaces can be approached from these different aspects, and we cannot forget practice, of course, while at the same time delineating the concepts and technologies. These are all intertwined and going on simultaneously, and eventually that should serve a business goal or a benefit for the stakeholders. Now, a smart autonomy is a test bed where we can test and exploit latest technologies. Autonomy is part of city of Espoo, which is neighboring Helsinki, and now growing to 20,000 people about home and office area. There we have an infrastructure for smart urban mobility lab, zero emission technologies, circular economy, sustainable food system, future urban energy, and all interconnected with data sharing and 5G technologies. It is a test bed, and it is constantly changing and used to understand how digitally enabled city works and in different scenarios. Now, for city planning purposes, most of the buildings are connected so that we can follow energy usage, and data from public transportation is flowing to the same system. Now, there are more than 2,000 vehicles in the public transportation in Helsinki area, which have their own information platforms producing a lot of data. There are smart charging stations which give real-time data of charging status. Lampposts are integrated with 5G connectivity. And these data sets can be linked via data space technologies, as some of them already are. So it is a test bed. But one needs to take into account many challenges of data spaces, such as consent, how to do interoperability, how to do trust, which need to be addressed in a flexible and scalable manner. So what we do is that we bring in companies to test their solutions with us and help them converge with current developments. And for European data spaces in general, convergence of industries is really required and a must. Now, what's more, when using IDSA in this case as a way to connect services, the point is that we create data sharing scheme between different services in a standard manner. Semantics or the vocabulary may be different between different domains, so therefore we have experimented with a company whose service is to harmonize data. City planning is one of the best examples here, since it's benefits can be understood quite quickly, and the more we measure, the more accurate understanding we get of the functions in the city. A service provider can take a connector into use and describe its data to a data broker, and then if the key performance indicators of sustainability, for example, are well established, then the sustainability of the city is known. Also, trusted data can be shared there. So much of this is in experimentation phase, and as are these other data sharing developments in Europe, many different instruments are available at the moment for example, in Horizon Europe and Digital Europe programs, and that what we look at. But anyhow, the platform exists, and gradually more companies will be included. Here we can see now the point made earlier, and this is that the ecosystem of stakeholders needed, and it's very important. Okay. So one of the main points in smart autonomy is, of course, this standardized interoperability. So just recently, 4 central organizations on data sharing formed an alliance to ensure interoperability of different approaches. But not only interoperability, also framing data spaces. How do you conceive data spaces, and what do you need in order to create them? Furthermore, data spaces radar established by IDSA is enhanced with the support of the 4 organizations to catch the progress of Europe towards the digital market. Maturity model is under development to capture all the necessary aspects when constructing data spaces. All right, so this was a very brief outlook what happens in Finland and how that effort is linked to European developments. So we do not only follow, but are actively involved with the European progress, and therefore, like VTT is IDSA Finland hub and a member of GAIAX hub Finland, but digital market in Europe is an European matter, and we are here to collaborate with our European colleagues. So thank you very much for having this opportunity to present the Finnish approaches to data spaces in smart cities.
Thanks so much, Tomo. Well, I've made a lot of notes during that. A great presentation, thanks. So if I pick out just 3 things that I wrote down, I first of all wrote down associations, and then value and planning. I think that the planning and the city planning is something I'm sure we'll be coming back to later on today, because that really does tie in with the opportunities that there are for city digital twins. But perhaps ask regarding associations, it is striking that these so many different organizations, the Big Data Value Association, IDSA, GAIAX, Fireware Foundation, it's a rather large and, well, from the outside, it's perhaps an intimidating landscape of many different players and organizations. And how would you, in a short way, summarize the contributions that each of the different associations is making, or in what way they would be each relevant for data sharing in the city digital twin field? Again, muted, please.
Yeah, okay, Graham, thank you for the question. Yeah, indeed, this is an issue to when you look at the developments in Europe recently. So there are many alliances and organizations which is very difficult to count or even follow that what's going on. So I think the central organizations that were here mentioned, these are, if we concentrate on them, so I think there is this let's say there are like 3 organizations which are looking at how the technology is specified, and what is proposed by this business alliance, data space business alliance, is that these organizations are aligning their specifications and technologies so that the data spaces can really make happen and be actionable. And Big Data Value Association is not a technical specification organizations as such, but BDVA is counting on that the specification and this understanding comes from these organizations. It's more research oriented and then research oriented in a way that it's forward looking in let's say looking at the next steps of this development and evolution of data spaces. So that's my understanding. But if we start talking about the other organizations, then this is very big session.
Okay, well, thanks for that. That's, I think, a great start to our session today. And I'd like to move on next to Stefano De Pamphilis from Fireware, and please share your presentation with us.
Good morning, and to everybody, ladies and gentlemen. Thank you for your kind presentation. Yes, my name is Stefano De Pamphilis. I'm the Chief Operating Officer at the Fireware Foundation, which is a non-for-profit organization under the German law. Yes, it's working. Yes. What Fireware brings and what we are talking about today. So, and in fact, explaining this and also maybe complementing a bit the answer that Tuomo gave to you, Graham, or kind of question about ESG, we in which Fireware Foundation is one of the founding partners. So Fireware, as somehow Tuomo said, is one of those organizations that is very much keen in not only providing specifications about implementing data spaces and digital, we are talking, but also these specifications are implemented in a curated framework of open source solutions components. They are royalty free, they are able to use. Those are complemented with other elements which are rather important in order to implement data spaces plus solutions, which are data models. With this respect, we just initiated an initiative called Smart Data Models, and you can find it smartdatamodels.org very easily, where more than 600 data models have been specified, not starting from scratch, starting from adoption or even implementing standards that are already out there. There are a lot of standards in specific domains that are already there, and there is no need to reinvent the wheel when we talk about adoption. Besides, technology standard is an ecosystem where there are more than 100 organizations being members, over 350 individuals works at the growth of the initiatives, and then the Fireware Foundation as the first servant of this community, the Fireware community, in order to support not only the further development of the technologies, but also the adoptions. We can say in the context of smart cities that more than 200 cities worldwide use Fireware, starting from larger cities and capitals like Vienna, and other that are in the process, like Berlin, or other large cities out Europe, like Kansas City or Atlanta in the US. The Fireware technologies are so flexible that allows very small city use. For instance, we have cities like Saint-Quentin in France, or other villages in Italy and so on. So that is the power of the technology, and the fact that they've been provided open source allowed all of this. But let's go on more on the topic. So the data spaces, as very well said by Tuomo before, is part of a continuous evolution on the data at the core of the understanding. So starting from the smart solution, which means having applications that are able to interact to the context. Now we are talking about of data spaces where the idea is that between representation of assets, in this case cities, of course, are shared across not only the various departments of the organization, across sectors, and this is very important. Of course, in order to do that, there are some elements that need to be understood. So, which, according to our fundamental principles in data spaces for the data economy. First of all, it is important to understand the fact that everybody, that one of the important principles of this is that they publish data without knowing who are the customer a priori. This is an important element, but they are confident that the customers are able to consume this. On the other side, the customers, they know that there will be a place or set of places where they can find data good in order to implement some business. Now, business here is in terms of not only just commercial aspect, but also benefits for the society, like the cities that we speak afterwards will sell. Of course, in order to do this, it is important that everybody speaks the same language. As just to make an example, today we are all speaking English. Today we are all speaking about a certain topic, data spaces and digital twins, so we have a clear semantic around, and also a clear mechanism for identity and access management. For instance, I have a code for pushing forward and back eventually my slides, and of course my code is not the same of Graham or Tuomo before or the next speakers. So just to make an example of what it is, what Fireware does for that, we recently published a position paper that you can find on our portal, where all these elements explained before as principle have been declined. So first of all, the language is the NGS-ILD standard by ETSI. Actually, the standard was, before becoming an ETSI standard, was a standard pushed forward by us, and then ETSI took it on board, and now is clearly evolving with also a wider set of organizations working on it. A second element, semantics and understanding, is about this Smart Data Model initiative, which I explained before. And then also the identity and access management at organization level. There are several components that are used. Besides, what I think is also important is the integration with digital ledger technologies, namely blockchains, in order to trace the data trading and the management, the governance, and this. This is a key element when we build the things. So about the standard, the NGS-ILD, that's the place where you define all the various components of your context, and then to a component that implements these standards, you create the data representation of the digital twins that you want to have. So it is important to say this, so just the data part of a digital twin. But is the core at this stage. And using the various technologies, you can build an architecture where the various systems that you see into the being part of a data space, they can share information and allow consumers to access the various information. Because why? Because they have clear and well-defined identity management. There is a trust authority that guarantee the ownership and the usage of the data. The data models that allow to understand which data are provided in the various contexts, and so that this data can be shared was the production of things. Interestingly, these components that we put in this architecture, which is also based on some other component initiative, for instance, of international data spaces, IDS, is that the key component, they are very much aligned with an initiative of the European Commission that was CEF Digital. This initiative just ended, but was the place where several building blocks have been produced and given to endorse to European public administration in order to implement and to support their digital transformation. Of course, we are talking about the context broker. We are talking about the EID as the building block for supporting the work of the trust authority. The EID is also at the core of the European card security aspect. And of course, the component on blockchain, that is EPSI, which support the of the transaction happening in the data space and in and out the data space. So to conclude, why it's important to consider fireware and which is the role of fireware in data space. First of all, that the technology of fireware are there since now years, and they are used, as I said, in many cities, in many places, and since a while. And the first use case is implementing data spaces using the fireware technology plus other standards are expected for now. So we are starting to implement at this moment. There is this strong ecosystem of more than 100 organization members. They are all between public and private organizations. So as a member, not only have large corporation or SMEs, but also, for instance, cities themselves that they want to push forward idea, requirements, and things. We have a portfolio of more than 150 solutions based on fireware that can be used and from our community, and also the fact that then 20 fireware apps worldwide exist in order to create a local competence center where people speak the language, where people understand the culture, where people share the same issues, and where this community are materialized. Last but not least, as Tuomo mentioned before, we are the founder, among the founders of the Database Business Alliance, which I can say, Graham, is not there to intimidate anybody, even the contrary, because as this is based on several organizations, it's also open for new membership. So happy to also is there to support, actually. As I said, all the organization here are not-for-profit alliances that engage several stakeholders from public to private, and this is there to help the growth and the adoption of data spaces in Europe. Thank
you. Thanks, Stefano. So I think it's not so much intimidation, but rather just the feeling of being overwhelmed by the complexity of the landscape. But that was a great presentation. Many of the things that came up there are things that we've also been discussing in our Digital Twin City Centre in Gothenburg. Data models, data provenance, and also how to take advantage of existing standards. And what you say about trying to adopt as far as possible, I think, is a well-made point. I think we should move on to the other presenters now. I think there's a lot that we'll be coming back to in the discussion. But I'd like to invite next Desi Petrova Antonova from the Gate Institute to present and to tell us about the work that's happening with city digital twins in Sofia. Please.
Thank you. Thank you, Graham. Hi, everybody. I'm very excited to be here in this panel and to present the City Digital Twin pilot project of Gate Institute. Could you please start from the beginning, the presentation? So, even though the single definition of digital twin in the geospatial domain is lacking, there is consensus that it should be based on 3D city models containing objects with geometric and semantic information. It should contain real-time sensor data, and it should integrate a variety of analysis and simulations to be able to make the best design, planning, and intervention decisions. To support those decisions, all information should be presented to the stakeholders like citizens, decision makers, experts in a user-friendly visualization of the digital twin in a one-stop shop dashboard. We aim to implement the digital twin as a technical solution that scales to real-world problems, as opposite to only an abstract vision that is focused only in partial solutions. So our first goal is to create a 3D city model of Sofia and to continuously enrich the model with additional data in order to be used in different kinds of simulation, analysis, and visualizations in urban processes and environment. And last but not least, we would like to promote the digital twin for decision making. District Ordinance of Sofia is selected as a pilot area for development of the digital twin. It is located on a hill south of the old town of Sofia and extends to the northern foothills of Vituša Mountain. Here, the technological framework for development of the city model is presented. The model integrates cadastral data describing different urban objects such as buildings, green spaces, relief, etc. In order to achieve a higher level of detail, we are working of enrichment of the model using orthophotos and satellite images. The core 3D model is based on a widely adopted standard like CityGML. In addition, domain-specific data models are used or specially elaborated for specific use cases. Finally, the 3D model is visualized using Cesium Virtual Globe, allowing user interaction and perception. The 3D model presented here covers the area of District Woznets in Sofia. Continuing to integrate more data, the 3D model is enriched at neighborhood level. So in addition to the buildings and relief, green spaces and road network infrastructure is also modeled. The 3D model is not only geometric representation of the urban environment. It is mainly based on semantic data acting as a storage and a dashboard for citizen dialogue. Our understanding is that without semantic data, the model is a person without opinion. We are planning to integrate IoT data in the city model, which is already supported in version 3.0 of CityGML standard. The data will be collected in Gate City Living Lab, which is currently under construction. The WAP will be equipped with sensor stations for monitoring of air quality, including gases and particles, environment parameters such as temperature, humidity, and wind direction and speed, as well as noise. Sensors for people counting will be also delivered, and the WAP will be also equipped with a drone for remote sensing through LiDAR and cameras. We are working on several use cases in collaboration with Sofia municipality, our colleagues from Chalmers University of Technology and University of Twente, as well as companies supporting us with data and software tools. The main focus is on urban planning and design and air quality analysis and simulation. The parametric urban planning is a collaborative work between GATE and Sofia Plan, which is a municipal enterprise responsible for the spatial and strategic planning of Sofia municipality. We developed a tool that provides data-driven decision support on urban planning based on preliminary defined neighborhood indicators related to population density, access to social infrastructure, transport connectivity, etc. Investing in social infrastructure is critical to resolve the many challenges created by rapid urbanization. In such context, again, in cooperation with Sofia Plan and Sofia municipality, we are working on a use case for analysis of the kindergarten's demand, integrating demographic data and data for built environment. Air pollution is still a major health concern in Europe. People in bigger cities like Sofia tend to be exposed to higher concentrations of air pollutants. In such context, we are performing both temporal and spatial analysis of air quality. Here you can see the spatial prediction of the nitrogen dioxide during the day. The information from the sensors can be used to understand the air quality at any location in the city. In addition, we are working on the development of sub-city level fluid dynamics models capable of simulating the dispersion and concentration of different pollutants. The goal is to create a high-fidelity city model for identification of pollution sources and mechanisms assessing different scenarios for city development. With the help of CFD analysis, indoor air quality and thermal comfort is simulated. The CFD model can be connected to data management system, resulting in a digital twin of the indoor environment. The digital twin will be used to monitor and predict the air quality and thermal comfort score in real time. And this brings me to the end of my presentation. Stay with us after this session to know more about Gate City use cases from our researchers.
Okay, thank you, Desi. So a lot going on there with analysis, simulation, noted also the enrichment of data, the semantic enrichment, I think very important. And you also mentioned real-time data there. Thanks for that overview of what's happening at the moment in Sofia. And I'd like to turn next to Anders Log, who is Director for the Digital Twin City Centre in Gothenburg. Please share your presentation with us, and we look forward to hearing about what's happening in Gothenburg.
Yeah, so please show my slides. Thank you. So next slide, please. So I come from something called the Digital Twin Cities Center, which is hosted by Chalmers University of Technology in Gothenburg, Sweden. And we are a national competence center devoted to the study of digital twins for cities and regions. We have around 30 partners, most of them from Swedish academia, from Swedish municipalities and Swedish industry working in the built environment. And one of our partners is the GATE Institute, one of our main international partners. And GATE has been with us since the start of the center, and this is a very good fit both for us and GATE, I think, since we are both working almost overlapping activities within this area of digital twins for cities. So many good joint projects going on, and already some good results from that collaboration. So next slide, please. So our work is organized into 8 different research areas. So they are described here on this this page with some images. So the first one is research area 0, which is a digital twin platform. That's sort of the infrastructure or the basis for all the activities at the center. And itself, it's a research area in how to develop such a platform using open standards, open source, and open data. And we are now then supporting research and innovation within all these other research areas like urban planning and design, architectural and structural design, digital construction, modeling, simulation going on both above ground, so wind simulation, air quality simulation, those kinds of things, and also below ground. And that's particularly interesting in Gothenburg because our city is built on clay. So you want to know what happens, how big infrastructure existing underground, how that relates to new activities going on in the city. Visualization or realization, of course, is an interesting topic in itself. So how, when you have all these simulations, you have all this data, how do you communicate that in the best possible way? And that can be different depending on who is the stakeholder and what is the purpose of the modeling and the simulation. And of course, data management is also basis for this. How do we create our data models? How do we store our data? How do we make sure that data can flow freely between these different research areas and activities? We also have a work package on innovation and education. So making sure that the methods that we create both become useful to the industry partners and in general the society, and also making sure that we integrate this into both university education, so in our university courses and programs, and also to our partners and the industry at wide. So continued education is also a part of our mission. So next slide, please. So I will mention a few things that we have been working on. So this slide here gives a glimpse into the pipeline that we have developed for model for geometry and mesh generation. So we want to be able to work with raw data. So the data that is available both from the national cadastre, so public standby data, and also from the municipalities themselves. And this usually comes in the form of point clouds from scans, from aerial scans of the city, and also from property maps. So you have this for the whole of Sweden, and I think for most other countries as well. You have these data sets, and then we want to be able to combine them and create high quality 3D models. And this follows a pipeline where we first we take these property maps, we make sure that the data is of good quality, so we pre-process, we clean it up, make sure it has good quality, and then we combine this with the point clouds. So basically we take the buildings and we extrude them in the sort of height or z direction based on the point clouds. At this point we can now automatically generate high quality meshes for different purposes from this raw data in an automatic, efficient, and standardized way. And we are now looking into how can we improve this. So something to point out here is that you might need data for different purposes, and depending on whether you want to use it for, say, a visualization of a future scenario in a city, that data you need then can be very different from the data you need if you want to do a wind simulation. Then you might need, as in this lower right figure here, to create, say, a tetrahedral mesh of the air surrounding the city and the buildings. That's very different from having a surface mesh for visualization. So here you see a couple of examples of data we have created. So if we move forward to those slides, please. Next slide. Yeah, this one, and maybe next one. And next one. So here you see an example of a part of the capital of Sweden, Stockholm, that we generated last week. When just by marking this region on the map and pressing a button, we get this this mesh, and it's a high quality mesh that can be used directly for both visualization and simulation modeling. So, for example, air quality and wind simulations. So next slide, please. So together with Gate, we are working on extending our current pipeline from generating these quite simple LOD1, so flat roofs models, to LOD2 and LOD3. So we will then be using, we have ongoing work where we use machine learning to identify the shapes and topologies of the roofs, combining this with the point cloud data to generate detailed and high quality meshes for cities. So that is our current, so one of our sort of most interesting current projects together with Jute. So next slide, please. And when you have these meshes, you can do things like large-scale, high-performance wind simulation. So this is an example from an area close to our university in Sweden, performed by the Fraunhofer Chalmers Institute, which is also a partner in our center. So they use the same technology refined that they used for doing simulations of, say, the wind around cars, to do the same kind of thing, CFD for cities. Of course, it's a different scale, new things come into play, but basically taking this methodology and adapting it to this new situation of wind simulation in cities. So next slide, please. So this is my final slide. So I would like to point out a few challenges that I've seen in our work so far. And those relate to data access, complexity, and sustainability. So when it comes to data, there are many challenges, of course, but one of them is just getting access to the data. And this is not a technical or legal issue. It's more sort of a human issue. People have data, they own data, and they don't want to share it because they feel that we put some effort into generating this data. Maybe we paid someone to generate the data for us. So they feel an ownership, and that is sort of the first thing to unlock if you want to get access to data. How can you ask someone to share their data, even if it's just for research? I find that it's often difficult to get even municipalities to give their data freely, no strings attached, to a research project. Complexity, of course. I mean, building a data model, a representation of a city is bound to be complex because the city itself is very complex. It has been built over many hundred years, and of course, mirroring that in a digital twin will be a complex model if you want to capture all the aspects of the physical city. And lastly, sustainability. You can create pilot projects. You can create impressive so-called digital twins of cities. But the question is, what will happen next day? What will happen next year? What will happen in 5 years? So we need to put more focus on the processes of how we generate cities automatically from raw data, so that when new raw data becomes available, that just feeds into the system and you get a new model. So it's continuously updated. So we make sure that the digital twins that we create don't become artifacts or exhibition objects that we can showcase, and then they will sort of slowly fade into and become obsolete. So those are my some points I want to put out there. Okay, thank you very much.
Thank you, Anders. So again, that's a great overview of what's happening with DTCC. And I know in DTCC we are very fortunate to have many very engaged stakeholders, both the industry and the municipalities. And I think this is a good time now to move on to the final presenter today. We have Gensho Keresov, who is representing the Sofia municipality, who I know are working very closely with the Gates Centre And hopefully that's a collaboration which benefits both sides. So please, I'll pass over to you now. Please share your presentation with us.
Yeah, thank you so much. It really has been a great pleasure to work with the Gate Institute because digital twins is a major topic for us. I want to refer to what Anders finished with, that it is really important to have the digital twins not just as an artifact or a showcase of technology, but something that is the daily management of the city. So before we dive into that, just to share for a bit what our Department of Digitalization, Innovation and Economic Development is doing for context for the audience. So we have had great progress in making Sofia a really innovative city and the city of the future. We are blessed to have a very strong technological community in Sofia, and the IT ecosystem and the innovative business is the main driver for both economic growth and innovation within the city. So we were ranked at 19th in the this year's FDI Tech and Cities of the Future competition. And this is because of the work of the entire community and ecosystem. The entire digital transformation of the city is based on a very detailed plan, which is the digital transformation strategy and the action plan of implementing it. We are working on 15 key topics to make the city and the municipality as digital as possible. We are on the one hand working on transforming the processes and the digital services for citizens within the municipality as an administration. And on the other hand, we are working towards creating the conditions for Sofia to continue growing and become smarter and smarter as a city, and to support the innovative businesses. We have launched multiple initiatives already in the last year with this regard. And one of our major successes was creating the Sandbox for Innovation. This is something like a VC program that the municipality is supporting startups and innovative companies, that when they identify a city's challenge and they can apply their technology to solve it, we are welcoming them and starting to experiment, create a small pilot project and a definite use case that we can scale up afterwards. And instead of looking to get returns as a VC would do, what the municipality is looking for is public impact. We afterwards analyze those projects and decide where do we want to scale them, and we will look for funding for large-scale implementation going forward. And Gate has been really useful, and we are now working on analyzing some of those projects to make sure that they are scalable and they have a sustainable impact. Now, the digital twin is a particular case for us. As mentioned before and from all the other speakers, it is really a tool for improving the life of the citizens. In Sofia, we are especially focused on facilitating the urban processes, and what is really crucial for us is making data-driven decision-making. We want to use the digital twin as a tool to simulate every major change that we want to make in the city. For example, let's say we want to build a skyscraper or a really large building. There's an investor, or it's part of the plan of the chief architect. Sofia is a really sophisticated system, like any major city. And when you do something, when you want to create something like that, such a change in the landscape, this of course affects air conditioning, it affects traffic, it affects residency. So our end goal here and our biggest aim is to have a tool that will allow us to simulate how this change that we want to make in the city will impact all the other systems. So the most important thing in the digital twins for us is to assist us with decision making, not just to have expert assessments and feedback from the community, but to make sure that for everything that we do in the city, we are supported by the data and by a simulative model that can predict with a certain amount, with a high amount of certainty, what the effect will be to the community and to all the other systems. This, of course, will bring us a lot of benefits, like having more effective resource allocation. It's a huge topic for us that we need to be better and better in allocating resources and making sure that the money are spent in a way that sustainably change the lives of people for the better, and we have an effect of our investments that is building on top of each other. We are heavily looking forward to making all our investments as sustainable as possible now. Every project that we are doing, especially in our department, is aimed into providing as much data as possible. And we are now also starting to experiment together with GATE to see what for. A short example, we created the first entirely smart kindergarten in Sofia. We have invested in sustainable energy resources and a smart system for managing all the expenses and all the resources that are being spent by the administration of the kindergarten. And we try to tackle the air quality inside. Air quality in general is a huge topic, as also Desi mentioned, for Sofia. But we wanted to also start exploring what happens in the inside. And we installed sensors and this digital canary that helps children to be more aware of the quality of the air that they're breathing. And it also helps the teachers to make sure that the quality on the inside is better. The main challenge there was that everyone in Sofia is concerned with the fine dust particles, and it turns out that in the inside, in the offices, in the kindergartens, in the schools, actually the CO2 levels is the major issue. So we already have had this for maybe 6 months now, and we have provided all this data to the GATE, and now we want to try to analyze and to model what the effect would be if we implement such solutions across the entire city, in all kindergartens and in all schools, for example. We can also expand that to all the hospitals in Sofia and different kind of public buildings as well. We have multiple projects that we work in. As we mentioned, we want to have every project that we invest in to be data-driven and to gather as much data as possible, so we can actually have all of this data integrated into the digital twin, and to make sure that we have as much data-driven planning as possible. There are multiple other projects that we're working on as a department, and they all come together into this grand vision. And there are also projects that we work in that are policy-driven. We are part of multiple international networks like Policy Cloud, IURC, and the 100 Intelligent Cities Challenge that we get from our partner cities different good examples about how to use data for policy making. And this is also important for us to integrate our project together with GATE with these good practices that our international network is involved in. And we also are involved in different reports and analysis that can find their place into the digital twin, because we as a city has also economic data and data that is not just from the urban environment, that can also be part of the twins. So I also want to share this very important example for us that Desi mentioned. Kindergartens is a huge challenge for the people of Sofia. We have fewer kindergartens than are necessary for the kids around. So we created last year a system that is automatically enrolling the children to the most appropriate kindergarten that they have. next to them. The issue here was, though, that how do we regionalize those kindergartens? We have many people living in the neighborhood, and we have to make sure that we have the most fair competition for those kindergarten slots. We provided all the data to the Gate Institute, and we're now trying to make a really data-driven regionalizing. We took the example of Paris and different French cities. They have this principle of a 15-minute city. The idea is that you need to have everything that you need for your daily life within 15 minutes, or a theater or a supermarket, or to be able to travel to your workplace, all within 15 minutes. So we took this idea and we asked, can we do really a map of the city in which every kindergarten is with 10-minute walk from the homes of the parents and the children that need to go there. So we're very excited about this, and we're looking forward to getting the first analysis from Gate, and hopefully we will be able to drive this moving forward as the first use case for data-driven decision making, entirely coming from a digital twin project, to make sure that the children and the parents are with the feeling that we have the utmost fair competition for having the children in the public kindergartens. So this is in short, and we are very excited about this project. We are very grateful to have the chance to work with Gate on those topics, and we're very much looking forward for the first results coming out of our cooperation.
Thanks very much, Gesho. So again, many of the things that are echo back to things later this morning, the importance of sustainability and scalability in both the digital city, but also in the real city itself. You stress the importance of the partnerships, both partnerships with academia, with Gate, with also the international partners through the many collaborations that you're involved in. And also, it stuck with me mentioned the importance of the digital twin city as a tool, not just as a showcase, but something which is there working day to day, supporting the data-driven decisions that the city is making. So thanks for that. Regarding the timing, we are at the time when we were due to finish, but we did start a few minutes late. I would at least like to have one round of questions. So I'd just like to ask each of you perhaps to comment on perhaps one or two words or phrases that have stood out for you in the presentations today, or particular words or phrases associated with challenges that you would like the audience to take with us going forward. So perhaps, Tuomo, I can turn to you first. Some reflections or challenges that we should take with us.
Yeah, I think there has been really great presentations, and thank you for that. Those talks, and clearly there's a lot of things to do, and now that this the design of cities and sustainability in many ways, there are different meanings are very important for cities eventually. So I think there's a lot of collaboration there to do and to work on. It's splendid to have this kind of event and understanding the many developments of this designing and tools and the efforts that have been done, and also the domains which are very important. And it seems that it's not exactly the same in every city, but there's many learnings from each other. Thank you very much.
Thanks, Tuomo. And Stefano, can I turn to you next, either your reflections or the challenges you see?
Thank you, Graham. One word, I would like to comment on one of the challenge that Andreas pushed forward, because I think it's rather important, is the one on sustainability. This is key for all of us in ICT when we do some experiments or some use cases and this. And then it's the challenge that we as a community, we have to be sure that we are able to show the benefits of what we do. So it's not only to have a committed stakeholder like we have here in this panel. Thank you, Kencho, for your presentation. Great, and show a huge commitment from your city. But we have to show also the fact that these solutions are good. And this is the very important aspect that I would take on board, because this is always there. It's always there. The sustainability of what we do and the fact that we are able to show to the general public that we are working for the benefit of all.
Thanks, Stefano. And Desi, please.
Thank you, Graham. First, I want to join the challenge of funders about the data, how to convince the stakeholders to share their data and to use data as a decision support tool. And the second one that I was to mention that I'm very happy that we have created in GATE in the Future Cities application area a multidisciplinary team, because we need not only machine learning and AI, but we need also a lot of domain expertise in order to model the city to create more precise data models. And of course, we need standardizations, and we are working on adoption of file-aware data models in our use cases. So thank you.
Thanks, Desi. And Anders, please.
Yeah, something that I think actually you mentioned, Graham, is that, and something that connects to what I mentioned about this challenge about complexity. So the city is complex, and there are complex challenges to solve. But when we now, as a society, are trying to solve these challenges, we are building organizations, we're building software, we're building data models, standards, and so on, and that in itself is a quite complex world. So I find it a challenge to relate to all these standards and initiatives going around, both nationally and in Europe and internationally. So how do you relate to all these efforts and initiatives? How can you, I mean, there are so many. So how can you find time to engage in all these? And you really need to engage with many of them, because, I mean, if you're going to model a city, you need so many things. So it's very demanding to sort of stay on top on what is the best practice, what is the best API, what is the best standard to use for each particular case that you need to cover when you try to build the digital twin of your city. So that's my remark.
Thanks, Anders. Well, that's great. Thanks, Anders. And finally, Jensho, please. Check you're unmuted, please.
Sorry. For us also, as Desi mentioned, our biggest challenge is breaking the silos of data, like making sure that all stakeholders are willing to share the data and to find the proper framework in which we can open as much of this data as possible to the public. Because of course there will be sensitive data, but how do we make sure that the data that we have as municipality, as companies, as citizens is joined together in a common model that is able, that we can actually open to citizens? Because this is how innovation is born, in my opinion. We provide as much information as data as possible to innovative people and companies, and then they can come and say, look, you have an issue here, this is how we can solve it together. So that will be the main thing. How do we break the silos, create a joint model where all this data is connected and understandable in a common model, and open as much as it to the public, so we can have innovation coming out of it.
Thanks. That's, I think, some great points to end on. Thanks to all of you. It's been a fascinating session. I feel that there are many common themes, even though we're spanning quite a broad spectrum, from those focusing on perhaps more the technological side of data sharing, right through to the eventual use of data in decision making. But I think that this is important, that we have all of these partners involved, that there's good communication channels among us all. And as Desi was mentioning, the importance of multidisciplinary approaches. There's so much to do to deal with the complexities that we all face. So I think that we've reached the end of our time for this morning. I just would like to thank you all once again for your participation. And I look forward to what's going to happen next, and thinking ahead to next year's forum, how things are going to have developed in the Gate Institute in this field by then. So we'll leave it there for today, and once again, thank you.
Thank you, Graham, for moderating this session, and thank you for all participants
We don't hear you,
share their
Sylvia.
vision. Oh, sorry, I was muted. Again, thank you, Graham, for
Sylvia,
moderating.
we don't hear you.
Still? Do you hear me now? Thank you, Graham, for moderating the session, and all the speakers for this, for sharing their thoughts and sharing the challenges and directions for future work. And really looking forward next year to see what we have achieved in cooperation together, exchanging ideas and experience. And now we will continue with the videos for our researchers. We will start with the researchers working in future cities, where Desi is leading this team, quite international, multidisciplinary. And then the videos from digital health domain where we're working, and maybe there will be 5 minutes break, and then in 2 o'clock Eastern European time we'll continue with this information session, where also Milena Dobrova, who is leading the efforts in Bulgaria, will present our work there together with our partners and cooperation. Thank you very much, and we'll continue with the videos, and see you 2 o'clock for the next online session.
Hi, my name is Peter Christoph. I'm an experienced researcher at the Gate Institute, and I work in the Future Cities application domain, and more specifically on the analysis and modeling of urban air quality. In my work, I use statistical and mathematical methods to quantify the uncertainty in numerical simulations and experimental measurements. I am part of a highly motivated team dedicated to delivering outstanding results. Our work has been validated on national and international level, where we constantly attract collaborations with individuals and institutions who appreciate the potential and importance of our research. My research produces methods and tools related to the development of uncertainty-aware digital twins, which by design should have a sufficiently high level of fidelity to replace the physical systems they correspond to. For example, here you can see results from a computational fluid dynamics simulations of a city in Japan. This simulation represents a test in a wind tunnel, seen on the right, and one in a computational domain, seen on the left. In the middle, you can see a statistical tool used to validate the computational framework. Moreover, we apply advanced statistical techniques to fuse information from different sensors located in different locations in Sofia city. You can see here on the right a map of the city overlaid with a nitrous oxide concentration prediction. This tool allows people to get a better picture of the quality of the air they breathe in. I collaborate with many individuals from academia and industry to increase the exposure of stakeholders to the fact that we do not live in a world that we fully understand, and this uncertainty must be quantified. For example, we have a strong ongoing collaboration with Chalmers University in Sweden, as well as their industrial and patent division, Chalmers Industry Technique. Collaborations with London metropolitan universities are also undergoing and look at different aspects of urban air quality modeling. Our research is supported strongly by Sofia municipality through information, different initiatives, and support. And technically, we collaborate with companies such as Develit, Telelink, and others who provide technical solutions for our needs. Developing digital twins is a challenging task. There are many nuances that need to be taken into account, and small deviations in unpredictable human behavior can have a significant impact on the inferences of the twin. However, my team and I are confident that through our research we will help policymakers take informed, evidence-based decisions. We also believe our work benefits the public as a whole by unlocking the potential of data that surrounds us to promote a healthier, more sustainable lifestyle for an engaged society.
Hi everyone, I am Radostin Mitkov and I'm a junior researcher at the Gate Institute. Today I'll be presenting my current work, and together with my colleagues Maria and Petar are working on the Future Cities research area at the Gate Institute, and more specifically we're currently working on the Digital Twin Cities project. In our work we use CFD simulations, which stands for computational fluid dynamics. Such type of simulations is often used to solve any type of fluid problems, and in our case we're using it to simulate wind flow environment in cities. We have defined two main types of simulations. The first one is urban simulations, which could also be called outdoor simulations. These include pedestrian, wind and thermal comfort, and also air pollution dispersion. The second type of simulations is the indoor simulations. These again include thermal comfort, air pollution dispersion, and assessment of the ventilation and heating efficiency. One of our use cases for the urban simulations includes this study of Krastova Vara in Sofia. We obtained our geometry from building footprints and created the 3D geometry. Then we simplified the geometry by removing any small gaps and small details which are problematic later when meshing the geometry. This is what the 3D geometry looks like, and which is ready for meshing. The model is then meshed using ANSYS Fluent, and currently we're in the process of simulation and obtaining preliminary results. Our second use case is an indoor simulation of a kindergarten room, and this is what the geometry of the kindergarten room looks like. We can see the beds, we can see the tables, the chairs, desks. We can also see the windows of the room and the doors, also the heaters. Also, we will take into account the children in the room, which are a main source of carbon dioxide, which is important in our study. And finally, we have a measuring device in one of the corners in the room, whose purpose is to measure the levels of the humidity levels, the temperature in the room, and also the levels of different gases such as carbon dioxide. And we're hoping to use CFD to validate this case against the experimental results, and hopefully to propose effective ventilation methods. And thank you for your attention.
Hey, my name is Stoyan. I'm a junior researcher at the Gate Institute, and I'm currently doing geospatial network analysis. I graduated from Imperial College London, where I got my master's in earthquake engineering, and I also hold a baccalaureate from the University of Liverpool in civil engineering. I'm currently working on big data and AI on geospatial data. So I'm going to present exactly what the Institute have been doing over the past year on this topic. So essentially what we have been doing is using open source tools for GIS that have GIS capabilities. And we have been developing these frameworks in order to develop tools for city planners or urbanists so that they can make better decisions within an urban environment. So in terms of technology, we looked at a lot of tools, and we selected these open source libraries that can create a good pipeline in order to deal with geospatial data and make data analysis on them. So essentially, we've developed this ecosystem of open source databases and open source analytical tools and open source machine learning tools and visualization tools in order to create full applications that can be then used by someone in the practicing world. So the foundation of why we actually started doing this was that we started working with Sofia Plan on. They have developed a process that's essentially they were able to calculate for each zone within the city what were the indicators within that space. So they could analyze. They created analysis based on indicators on how well this space was doing in terms of public infrastructure, in terms of gross floor area, and green spaces, and a lot of factors within the urban environment. And they provided us with this information, and they wanted us to do a generative design tool. So essentially something that could recommend how can we make this place better based on their analysis. So we've developed essentially a generative design tool, which is to say a tool that optimizes under certain criteria. It optimizes the geometry and provides a number of alternative plans that actually are suboptimal, and then from those plans, an urbanist can come and can take one depending on their expertise within the field. So we've developed a tool, and essentially what you have is empty parcels within. So for example, we make this on Rostova Vada, and what you have is this empty parcels, and we need to put buildings within them so that they're the optimal, in the best optimal position. And these buildings can either be, for example, parking or residential buildings, office buildings, kindergartens, what have you. So we've developed this, and there was a lot of mathematical consideration, but essentially we've used genetic algorithms in order to simulate different scenarios and then rank them and then perform some modeling on the essentially the genetic process, and then come up with the best optimal scenarios for this particular plan. So the result was a tool where an architect can scroll through different scenarios and decide on a plan that he likes best, essentially a catalog of plans. So that was the first problem that we tackled, and it only dealt with position in space and how to allocate buildings based on the requirements for space. But the second capability that we wanted to develop was the requirement of distance. So essentially, we wanted to calculate how far away is each kindergarten from the closest, each building from its closest kindergarten, and what kindergarten services which buildings based on distance alone. So we developed this again using this ecosystem, using these libraries, open source libraries in Python. We developed new functionalities on top of them in order to perform such analysis. So the result was a brand new model that essentially you can input geometry, you can input buildings and a public service, and it can tell you how well it's serviced based on that geometry. As a result, Sofia Plan actually published the findings on their website. So that was a good result. And the next step is not only to be able to calculate the coverage of existing buildings, but to be actually able to place new buildings in the most optimal positions. So essentially, if you're building kindergartens, you can position new kindergartens in the most optimal way as to service as many buildings as possible in the most optimal way, minimizing cost, optimizing position. So essentially, that's what we have been doing for the past year in this group. Thanks.
Hello, my name is Angus Pasov and I'm a junior researcher at Gate Institute. My application domain is future cities, and I'm also part of the Digital Twin project, which aim is to develop a 3D informational model of Sofia. My work is mostly related to the development and application of machine learning, and with more focus on computer vision systems. The idea or the main purpose of computer vision is to build systems which automatically can extract and analyze information about the 3D world from digital images. We work with different type of imagery taken by different devices. For example, we use a lot of aerial imageries, such as multispectral satellite images, also orthophotos taken by planes, and of course images taken by drones. In the following, you will see some of the tasks that we have been working on. Here you see an example results of projects which aim was to analyze satellite images and localize the buildings. The purpose of this work, or why is the information important, is because it provides useful insights for city modeling, also for cadastral inspection, and of course also for planning the infrastructure. Here you see some other examples. On the left side, you see a tile of an orthophoto, and next to it you see a segmentation mask indicating where are the edges of the rooftops. This information is important for analysis of the solar potential of the buildings. And on the right side, you see another task, which was basically to analyze the vegetation in the city. Using multispectral satellite imagery, we were able to relatively well segment the vegetation areas, and also to get information about its density. And lastly, this is a project that we have just started working on. The purpose is to build a system that can detect road damages. In this case, we have devices mounted on a vehicle or on several vehicles that capture videos of the road, and this information is then automatically analyzed to provide information first about where are the damages, and second, which class or predefined class do they belong to. Ultimately, this information would serve road maintenance agencies and potentially also citizens. So this was just a glimpse of what we are working on in the computer vision area. Thank you for your attention.
Hello again, everyone. I am Radostin Mitkov, and I'm a junior researcher at GATE. Together with my colleagues Maria and Peter, we are also working on wind simulations using IBFlow, which is a software developed by our partners at Chalmers University in Sweden. In order to be able to use this software in research applications or industrial applications, we first need to be confident in its validity. This means that we first need to validate the software against experimental results. And the case that you see here is a tall building which is surrounded by numerous shorter ones. And the goal is to compare the velocities from the experimental results and from the computational results at the points that you see on the right. Those are the measurement points around the central building. The second case is a real-world case from a city in Japan. And here the goal is to compare the results before and after the construction of 3 of the central buildings, which you can see that on the left are missing, and in the central image they're present. On the right image you can again see the measurement locations where velocity is measured and where later will become compared to computational results. Regarding the first case, we have performed a wind study from 3 different wind directions, and the results you can see on the plots on the right, where we compare the experimental values against computational values. We have also extracted the correlation coefficients between the experimental and computational results, and we have concluded that they agree rather well. Regarding the second case, we are currently in the process of simulating it, and we are hoping to be able to present more detailed results in the future. And thank you for your attention.
Hello, my name is Evgeny Marinov. I am experienced researcher at Gate Institute. My main focus at Gate is the research and development of machine learning algorithms and exploratory data analysis. I'm currently working on a project related to the analysis of air quality. We use data from air quality stations and meteorological data as well. All the stations are located in Sofia. My research consists of 2 parts. The first one is the exploratory data analysis. As we show here, we develop, this is a snapshot of a web publication that is dedicated for the citizens and the municipality to be able to see our exploratory data analysis. On the next slide, we can see clear patterns on daily basis for the different districts of Sofia. For example, these are for Druzhba, Pavlovo, Kupitutu, and Orlov Most. And we depict here the amount of nitrogen dioxide for the specific days. We also apply standard machine learning and statistical algorithms, but also more advanced machine learning algorithms. And we can say maybe some of the algorithms are linear tree, support vector machines, random forest, gradient boosting. In this research, actually, we show that the more novel machine learning algorithms outperform the older statistical methods. Here, for example, this is with blue, we have the original data, and in orange is our prediction on daily basis for some period of time, which is about 2 months. And we can clearly see that in some regions, our algorithm very accurately can predict the pattern. For estimation metrics, we use mean absolute error and root mean squared error, as well as R2 score. Also, we use linear tree, which is a novel method for machine learning time series analysis. With this approach, we can clearly see that there are variables or features with great importance. So actually our next step is to develop the web application more and to publish this research in a paper. Thank you for the attention.
Hello, my name is Monica Rapka and I'm a junior researcher at the Gate Institute. I work in the data engineering research area on the Urban Data Space project. In my work, I use Internet of Things and communication and software technologies like MQTT and REST APIs to solve the problem of collecting, pre-processing and transmitting live data from the environment sensor stations which are located on the territory of Sofia. To solve these problems, I access the existing APIs for these outdoor sensor stations, which provide access to the live sensor data, and I create Python programs to achieve the solutions. I work in close collaboration with my project team, as well as the researchers from Future City application area of GATE, working on a flagship project for building city digital twin. My work relies on the expertise acquired from previous research projects I have worked on at London Metropolitan University. My work is related to the development of a real-time data channel for the GATE platform, which enables acquisition of sensor data from live environment based on the use of existing APIs, asynchronous transmission of sensor data using MQTT messaging protocol, applying of various techniques and models for data cleaning, formatting, and transportation into a central server for further data integration and analysis. The main challenges I face come from two different directions: quality of the sensor data and reliability of the sensors. It is important that the data I am transporting into the server is valid and accurate. So far, the most important outcome of my work is the successful establishment of an operational channel for the collection of data from the live outdoor sensors in real time and its transmission to a central server where it's integrated with other systems. The benefits of my research work include enabling the real-time, streamlined analysis of live data on the GATE platform with offline investigation of historical data. They concern both the potential for establishment of live data channels on GATE platform in general, as well as the work of the Data Management Research Group of GATE. This achievement has potentially big impact on the environmental situation in the city, since it allows monitoring of the living environment and potentially improving the living conditions of the citizens. Currently, I am working on the collection and transmission of an indoor sensor station data, which will expand the scope of real-time data processing from the outdoor environments and further increase the impact of the digital technologies on the life of the people. Thank you.
Hello, my name is Wiktor Sowiński-Mydlarz. I am a researcher at the GATE Institute. I work in the containerization and visualization research area on the Urban Data Space project. In my work, I use a CityGML 3.0 conceptual model and QGIS 3.22 for pre-processing and editing of geodata. For visualization, I have containerized 3D city database and Cesium Ion platform for 3D geospatial data using Kubernetes and Docker. I have reviewed different data definition and data storage methodologies in CityGML 3.0 as well as encodings. I have also containerized Neo4j graph database. I work in close collaboration with my colleagues from the Urban Space project team. I have also been involved in the London Metropolitan University transformation project, giving me the expertise needed for the current project. My work involves overlaying the Krasowa Woda and Lozenec district 3D buildings mappings over OpenStreetMaps and ESRI World Imagery Terrain layer, as well as overlaying air quality stations locations and historical pollution data. The live data is coming from 21 air pollution stations through an API. I have implemented automatic hourly updating of measurements shown as heat maps and numerical values. There is a visualization of 5 years worth of average values, historical data from 5 air pollution stations. The following 4 KML layers can be switched on and off: Lozenec district 3D building model, devices, measurements, and historical layer. The main challenges I face involve working with KML, keyhole markup language layers, and maintaining the Python code which updates the layers. This means parsing JSON data, updating KML hourly with new data, and sending to Cesium Ion platform for visualization. The outcome of my work is picturing the measurements from air quality stations, shown as color-coded heat maps updated every hour. The benefit of my research is visual analysis of air quality measurements with option to correlate these measurements with historical data. This is the last step in the GATE platform operation where we can actually see the results in graphical form. Furthermore, I'm currently working on the machine learning, possibly neural network analysis of temporal and geospatial aspects of the historical data in conjunction with semantic data of types of buildings. This analysis will have a substantial impact on the way that we envisage the relationship between the most prolific polluters and those who suffer from the air pollution. Thank you for your time.
Hi, my name is Vasil Vasilev. I'm professor in artificial intelligence and intelligent systems and senior researcher at the GATE Institute. I work in the data engineering research area where I'm responsible for building the GATE platform. My previous work for GATE includes successful completion of technological pilot and one research project dedicated to resolving the concurrency in transaction processing, both are relevant to the development of the platform. I designed the GATE platform using two complementary principles, vertical layering and horizontal integration. They meet all requirements of GATE as a research and innovation institution, and at the same time, they allow implementing it as a cloud-based service-oriented architecture, highly desirable from the point of view of enabling parallel work on different themes. During the conceptualization of the platform, I developed a complex ontology, policy, and workflow models of data processing, which served the theoretical basis for developing of the various components of the platform and their integration on the private cloud of GATE Institute. I work in close collaboration with my colleagues from data management research area, the Bulgarian companies supporting GATE, and the international partners of GATE from Sweden, Norway, and Italy, as well as with my colleagues from London Metropolitan University. My work enables the efficient use of the available technical infrastructure of GATE for providing methodological and technological support of the teams working on research, innovation, and commercialization projects. It has a big impact on the entire GATE ecosystem as a potential bridge between academia and industry for digital transformation. The main challenges I faced come from two different directions. Firstly, insufficient technological experience for working in a cloud environment in Bulgaria. And secondly, the competition with the Bulgarian software industry, which diverts the attention of the most talented graduates towards taking relatively well-paid but not challenging enough jobs in industry. Because of that, my current team includes researchers from several countries on 3 different continents, Europe, Asia, and Africa. Currently, I'm leading the team of Urban Data Space project in collaboration with colleagues from Future City application domain. It's paving the way to migrate the existing projects of GATE to the platform and is preparing it for providing data services in the 4 main application domains in the focus of GATE Institute: Future City, Digital Healthcare, and Electronic Government and Smart Industry. Thank you for listening.
Hello, my name is Arvind Nakarami. I am a researcher at the GATE Institute. I focus on the data ingestion, persistence, and analysis research area on the Urban Data Space project.
To elaborate on my work a bit further, I have this presentation prepared. In my work, I use concepts of containerization to configure various services for ingesting sensor data from the client and storing it for further use. I have containerized services for MQTT for handling data ingestion, also Kafka for any future use, and MongoDB and Postgres for the persistence of data. I mainly configure these services and write scripts in Python for functionality and analysis of data. This is how I generally use and access the cloud server in Bulgaria to do my work. I work in close collaboration with my colleagues from the project team and researchers from the GATE Institute. My experience working in similar projects in London Metropolitan University has proven to be a valuable asset in the current scenario as well. I write scripts for functionality of the containers and configure them for access. My part in this project is highlighted in the boxes below, and I use these services and scripts for ingesting sensor data, ingesting planes, correlations, and such. This is basically how I have set up the containerization of the services. I have services for MQTT, Kafka, and MongoDB. Similarly, this is how I have set up the configured the ingestion of the data. This data that is being ingested on screen is for the devices, sensor devices that are in SOFIA, and the consequential measurements of those devices. Similarly, these devices, the data from those devices are stored in MongoDB and can be accessed as follows. The main challenges that I've followed in this project so far is of data quality. There is a lot of redundant, inconsistent, and non-relevant data that I've been receiving. For example, from the measurements data, each of these rows have the time, basically the column values that have been repeated in each and every single row, which is redundant. And for example, in the user complaints, there are different HTML tags and CSS tags that are mixed in with the data, which is non-relevant information. To conclude, I would like to share my current work progress. Currently, I'm working on the pre-processing and analysis of data for possible prediction and correlation scenarios. I have processed all the data that I've received from the sensors, and I have used it to calculate different covariance and correlation values, which I will plan to use for prediction. Thank you.
Hello, a quick introduction. My name is Dion Marianigan, and I'm an electronics lecturer and systems engineer, specializing in embedded systems, IoT, and human-machine interfacing, in particular, cybernetics. I'm a researcher at Gate Institute, and I work as a systems engineer in the Urban Data Space project. My main objectives were to first research existing air quality monitoring systems, then make an indoor version that could read various environmental data that then would be sent over to our servers and visualized using ThingSpeak. In my research, I used various sensors and technologies, such as embedded programming for IoT development and active real-time filtering, data acquisitions for gathering sensor data, cloud interfacing to ThingSpeak for visualization, designing circuit diagrams and professional PCBs, 3D modeling and printing for bespoke casing, successfully all combined to make a real-time indoor local air quality monitoring system that is planned to be mounted throughout London Metropolitan University for continuous monitoring and data gathering. This not only promotes further research, but actively moves towards a cleaner and healthier society. Though the path to success was faced by many challenges, as anomalies for the sensor readings, which was solved by implementing a Kalman filter, 3D modeling and printing issues, that was also solved by using high quality PLA plus filaments, and lastly, power management between the microcontroller and sensors, that was solved using smoothing. The next step is already under motion, as we've been researching how to detect the presence of mold within indoor environments and have been liaising with the local governments with potential collaboration with the NHS. Thank you all for listening.